All right, here's our video for 2.1a, solving one-sided equations notes. We're going to start by filling in these sentences up here. Well, first, actually, let's look at what our goal is. Our goal is to solve equations that look like these. And the reason they're called one-sided equations is because there's only one variable on one side. So, for example, this equation has an a in it on one side. It does not also have an a on the right-hand side. So there's only a's on the left. And that's what we mean by a one-sided equation. So, and there are multiple steps to these. So to solve equations with multiple steps, you will undo the operations by working backwards. So in this first example right here, it says our goal below is to solve for the variable h. So take a minute, just look at this equation. Think about what you remember from your previous math courses, how you might start solving this equation. And our goal is to solve for h. We do this by isolating the variable. In other words, we need to get the variable alone. So first, let's take a moment to see what is currently happening. So here's my variable. The closest thing to it is what's happening to it first, which is multiply 20. And then the second thing is farther away, and it's the plus 35. So the second thing is add 35. So in order to get the h by itself, so we have a solution that says h equals something, and we have h all alone, we're going to undo these steps backwards. So we're going to do the opposite of them, starting with the second one. So that's what we mean by working backwards. So to work backwards, the first thing we're going to do is the opposite of the last thing happening here. So the opposite of add 35 is subtract 35. And then the second thing we're going to do is undo the first thing we did over here. Multiply by 20. The opposite of that is divide by 20. All right, so we're going to do that now on the equation. We're going to start by subtracting 35 to both sides. Remember, an equation is in balance. The left side and the right side are equal. So to keep them equal, whatever we do to one side, we have to do to the other as well. So 100 minus 35 is 65, and that leaves me with 20h. And then the second thing we're going to do is divide by 20. So h is 65 divided by 20. We could simplify this fraction. We could start by dividing top and bottom by 5. And we get 13 over 4. Or if you wanted that as a decimal, it would be 3.25 if you did your long division. So I'm going to work through these problems down here. On number 2, the first thing that's happening to the y is it's being divided by 5. And the second thing is add 9. So if we're going to work backwards and then do the opposite, we need to do minus 9 times 5 to the y. So subtract 9 to both sides. That gives me y over 5 equals negative 3. Now multiply both sides by 5. Times 5 cancels out divide by 5, and I have negative 15. For number 3, first I find my variable d. The first thing happening to it is whatever's paired with it in the numerator, which is the minus 2. So there's a minus 2, and then after that is a divide by 3. So we're going to work backwards by doing first times 3 and then add 2. So multiply both sides by 3. And the times 3 cancels divide by 3. giving me D minus 2 equals 21. And then now I'm going to add 2 to both sides. D equals 23. On number 4, one thing that's different here is that we actually have some terms we can combine first. The 12 and the minus 5 makes 7. So I have 7 minus 4a equals 27. So now here's what's happening to my a. It's being multiplied by -4, and it's might be hard to tell, but because the 7 is a positive, we're going to say that it's a plus 7 that's happening to the a. And if we work backwards and undo the last step first by doing the opposite of it, that means we start by subtracting 7 to both sides, and then instead of times a -4, we're going to divide by a -4. So minus 7 to both sides leaves me -4a equals 20. And then dividing both sides by -4 gives me a equals -5. On number 5, here's my v variable that I am solving for. So the first thing happening to that is I'm multiplying by 2/9. And the second thing is I'm subtracting 6. So if I'm going to work backwards, I'm going to add 6 to both sides, and then instead of multiplying by 2/9, I'm going to divide by 2/9. But remember we reviewed that means dividing by a fraction means multiplying by the reciprocal. So I'm really going to multiply by 9/2. So add 6. So then I have 2/9 v equals 20. And then dividing by 2/9 is the same as multiplying by 9/2. So do that to both sides. 9/2 cancels 2/9. And then multiplying here, so to multiply by a fraction, when the other one's not a fraction, we're going to put it over 1, and then we're going to multiply across the top and across the bottom. So that gives me 180/2, and that simplifies to 90. And then on this last step, we have multiple things happening. So here's the first thing that's happening to D is the closest to it, which is times -3. Then we have a positive 10, which means plus 10. And then we have a divide by 4. So in this problem is different because it has 3 things happening. But the idea is the same. We're going to undo all those backwards. So we're going to start with doing the opposite of divide by 4, which is times 4. The opposite of plus 10 is minus 10. And the opposite of times -3 is divide -3. So I start by multiplying both sides by 4. That gives me -8 equals, and here a times 4 cancels out a divide by 4, leaving me 12 minus 3d. Now I subtract 10. That gives me -18 equals -3d. And then divide by -3, and I have d equals +6.